Sohcahtoa. Now, what's one of the key rules for Sohcahtoa? Sohcahtoa only works for right-angled triangles. So first thing to do is always check whether you've got a right-angled triangle or not. And then if you know what angle you're looking for, you can then label up the different sides. Start by labeling up the longest side, which is always the side opposite the right angle, and that's the hypotenuse. And then when you take a look at the angle and you look at the side opposite the angle, and that's labeled the opposite, and that then leaves you the third side, which is the adjacent. And sometimes if the triangles are a funny way round, it still applies exactly the same. That's our angle up at the top. Start by the hypotenuse, the longest side opposite the right angle, so that's the hypotenuse. Opposite the angle, opposite, and then the third side is the adjacent. So Sohcahtoa, and one of the ways to do this for each of the different equations is to push the middle letter up to the top in a triangle, and then you have the bottom left hand side, which in this case is sine, is equal to the top opposite divided by the bottom hypotenuse. So sine of the angle is equal to the opposite over the hypotenuse. So that's SO. The next one is K. So cos of the angle is equal to adjacent over hypotenuse. And the last one is TOA. So tan of the angle is equal to opposite over adjacent. And the things to remember when you're doing these sort of trigonometry questions, get yourself the diagram, label up all the sides, and then once you've labelled the sides up, you can then use Sohcahtoa to work out whether you're using So, Ka or Toa. Then you can substitute into your equation into the So, Ka or Toa, and by using that triangle you don't really need to do any rearranging because it gives it to you. And as it says at the bottom, make sure you show every piece of work. So let's take a practical example, past paper question. It says, calculate the length of the side QR in this triangle. So, number one, it's a right angle triangle, so we can use Sohcahtoa. We can label up the hypotenuse. And we've got the angle there, so the side opposite the angle is opposite, so that's our O, and our other side is the A. So now we can work out whether we're using So, Ka or Toa, because what we know is the side A, so we know an A has got to be in it. And what is it we're trying to find? We're trying to find QR. QR is over at the right hand side, isn't it? It's the opposite. So we're trying to find the opposite, and we know the adjacent. So that's O and A. So we know A, we're trying to find O. So let's write out Sohcahtoa. Now where does O and A come? They come there. So we're looking at TOA, aren't we? T-O-A. And what are we trying to find? We're trying to find O. So that's going to be the T times A, isn't it? So we've got the tan equals our side over 18, but using that TOA at the beginning, we could have just written our O is equal to tan 24 times 18, or 18 tan 24. And if you work that out, you get that as your answer. So Let's move on to one more question. That was a question, this question here was trying to find a side where we knew one of the other sides had an angle. What about if we know two sides and we're trying to find the angle? This is another past paper question. It's giving us those two sides and it says he wants to calculate the angle QPR. Well, we can't label up our triangle apart from the hypotenuse until we know which angle we're trying to find. We're trying to find QPR. So there's our QPR. We could label up our H always to start with, couldn't we? But once we've labelled the H, we don't know the O and the A until we know what angle we're looking for. That's our angle that we're looking for, QPR. So now we can work out which the opposite is. The opposite to that angle theta is the 9.6 down there. So the other side has to be the A. Now, what do we know and what are we trying to find? Well, we know the O and the H and we're trying to find the angle. So if we write our Sohcahtoa out again, we know O and H. So there's our O and H. So we are going to be using sine, SOH. Write it out like that with the O at the top. What is it we're trying to find? Well, we're trying to find the sine bit, aren't we? We know the O and the H. So we know that sine of the angle is equal to the O over the H, which is the 9.6 divided by 16.7. So how do we find out what theta is? Well, to find theta, it's not just 9.6 over 16.7, is it? It's the inverse sine, or sine to the minus 1 of 9.6 over 16.7. So use the shift key on your calculator, which will give you a sine to the minus 1. Sine to the minus 1, 9.6 over 16.7 gives you that, which is 35.1 degrees.